For a couple of days, we were focusing on switching. We covered major portion of switching. Few things that were left we will see again after this routing. Now, routing is showing the route to the packets for remote networks. Routing is showing the route to reach the remote network we can see those routes in the router's routing table. But who gives that route to the routing table? Two ways we learned in CCNA: static route and dynamic route. Two ways. Statically, we can give if the network is small. When you have a clear picture of topology, when you know where what is connected, it's possible for us to write the route statically. But in a large network, knowing the complete topology itself is a challenge because many administrators are there managing different portion of network. So knowing the complete topology itself is a challenge, even if you know. Deciding which one is the best path for each destination, which path is the best path for each destination is another challenge. Why? Because we only can see the number of wire that is going. To know the bandwidth of the wire, to know the delay that takes on the wire, to know the reliability of the wire, MTU of the wire, load on the wire, it's not possible. So writing static route is a big challenge in a large network. We rely on routing protocols. One of the popular protocol in IGP environment is OSPF. IGP, Interior Gateway Protocol. The protocol that runs within the enterprises. IGP. Open shortest path first is very popular. Open shortest path first uses an algorithm called shortest path first. Shortest path first. Shortest path first algorithm is also called as Dijkstra's algorithm. Dijkstra is the name of a person who came up with the algorithm to find the shortest path. There is another name for it, binary tree algorithm. We have all learned in colleges, in UG and PG. If you have done mathematics group or computer science group or physics group, definitely there is one paper in which you might have seen shortest path first. Windows programming was one of the paper I had in my master, which is also called a shortest path first algorithm, Dijkstra's algorithm. This SPF algorithm is used in various places. In Windows programming we use, in Google Map we use. In various places, this SPF algorithm is used. Routing protocol is also designed using this SPF algorithm, which is named as OSPF. Open shortest path first. OSPF is a routing protocol. SPF is not a routing protocol. SPF is just an algorithm. Open means what? Industry standard protocol. Open for anyone to use. Open shortest path first. Every routing protocol comes under a category. For example, RIP comes under distance vector. OSPF and ISIS comes under link state. Link state. Link state routing protocol. What does that mean? Based on the link state advertisement, the routers will learn the remote networks. The remote networks and their cost to reach the remote networks are learned by the routers by the advertisement called link state advertisement. You see, if every junction in the main road, no, you have junctions. If every junction will advertise the connected route, connected road, you have one junction. This road goes to Ainavaram. This road goes to Ambattur. This road goes to Purushavakam. This road goes to, what is that? Whatever, a Mount Road, let's say. So now, if this junction and the connected router path is advertised, likewise, this junction advertises this road, this junction here, Solinganallur, Old Madras Road, Navalur, Medavakam, what is this called? Whatever, Velachery. If every road starts advertising, every junction advertises the road, every junction now knows the entire map of the Chennai. Let's say all the junctions are talking. Let's call this junction as routers. All the routers are talking. This junction, Solinganallur router is saying, if you go straight at 7 kilometers, you will get Medavakam. If you go this way straight, like 10 kilometers, you will meet Velachery junction, Medavakam junction, Tambaram. So if every router advertises their connected roads and the cost, map can be easily formed now. You sitting here in Annanagar will come to know about the best path to reach Navalur. Navalur is on the way to Mahabalipuram. And this is Solinganallur. Immediate after that, the very next stopping is Navalur, where you can see Siemens, Nokia Siemens. And Wipro is here. Cognizant is here. These are the places I have visited, so I know this road very well. Now, every router learns about the networks connected to other routers, after some given time, every router knows the complete map of Chennai. Only the link state information, this road information, this road information, this road. This is what linking, connecting, link state advertisement. Which road, what is the cost, bandwidth of the road? 100 அடி சாலை, 80 அடி சாலை, 40 feet road, 80 feet road, 100 feet road. This all impacts in cost. So cost and the destination that the road takes you. So you see, link state advertisement is better than distance vector. RIP is an example of distance vector. What distance vector protocol do is, they will advertise the routing table. They will advertise their routing table. What do you have in the routing table? Only the best route to destinations. See, in the routing table, you will not have all possible routes. For example, from the Solingaluru to Medavakkam, the routing table will have only this path to Medavakkam, not this path via Vandalur to Tambaram and Medavakkam. It won't have that route. The Solingaluru router will have routing table to Medavakkam only showing this road. But there is also another road. You go straight and then I don't know all the names. After Medavakkam there is one blah blah blah. And then take right and then you will go to Vandalur and then you go to Tambaram and then get inside Christian whatever college and you come to Medavakkam like this. That road won't be there in the routing table. But when you advertise the link state, not only this link you advertise to reach Medavakkam, you also advertise this link to reach Medavakkam. See the difference between link state protocol and distance vector protocol. Distance vector protocol will advertise the routing table to the neighbor. Link state routing protocol advertises the link state information. Those link state advertisements are collected along with the router ID. Every router will have a unique ID like Solinganallur Junction, Anna Nagar Junction, Coimbatore Junction. There is a name for that junction. Yeah. Madhavaram Junction. Likewise, every router have got a unique ID. With that ID only, the advertisements, the connected road informations will be sent. So a router receives LSA along with who is giving this, from which router it is coming from. They are all collected in a memory location which is named as link state database. Every router has got a reservation for OSPF. In OSPF, there is again another reservation within only for this link state database, LSDB. This LSDB is a collection of LSU. LSU is collection of LSAs. Link state update is collection of link state advertisements. All link state updates are collected in a location called link state database, LSDB. Now this link state database will be used by this SPF algorithm to find the shortest path for each destination. And that shortest path which is filtered will be given to the routing table engine. There is a manager called Routing Information Base Manager or Routing Table Manager. The Routing Table Manager will receive this recommendation from OSPF. Routing Table Manager only decides whether to put it in the routing table or not. See, if you have a static route to reach a destination, administrative distance will be 1. Administrative distance. OSPF is also finding one route to that same destination. Going through all this process, it is recommending a route to same destination. Will the manager take OSPF? No. The reason is administrative distance of OSPF is 110. Even though it's a popular, well-known, famous protocol, OSPF, it is not kept in routing table. Why? Because there is another source for the same destination. Administrative distance matters if there is multiple source of route for same destination. OSPF or BGP or ISIS or RIP, they can only recommend the routes to the routing information base, routing table manager. The final decision maker is the routing table manager only. Fine. In this page, what you have to know after finishing this page, what you need to know. Link state protocols provide more detailed information, all available paths for each destination, whereas distance vector protocol only advertises the routing table, which is not all possible paths for destination. Routing table will have only the best route. When a best route is advertised, the receiver will know only the best route. For example, if you will get down in Chennai airport and if you want to go to if you want to go to Children's Park in Adyar, there are various ways you can know the route. One, you can call your friend who is in Chennai. He's on Chennai Vasi. Chennai Vasi will give you one route that he knows, which is familiar to him. Right? But there is another way also. You buy a map. As soon as you get out of that baggage collection area, you will find maps sold in small shops. Buy one map, Chennai map, position yourself in Meenambakkam, and also see where is that children's park. I think Anna Punga. Now you see, you will find many routes now in the map. You have many routes. That is what that LSDB, which is not available, which is unavailable in distance vector protocol running routers. Only a link state routing protocol can provide you this map from Meenambakkam to Adayar, Annapunga. These are the paths. One via Mount Road and take right. Another via Tambaram, Valacheri, take again one left U-turn. You will see the other side of Raj Bhavan. If they allow you, enter into Raj Bhavan, go out on the other end exit where governors enter. You will find one road, take right. There it is, Annapunga. Or you can also walk inside the forest if you are inside already Raj Bhavan, where I was brought up. You can walk inside the forest, you will see inside a back gate of the children's park. Not everyone is allowed to go through those doors, gates. Publics are not allowed. If you are having some people inside, you can try. So you got multiple ways to enter. You can also go straight to Paris Corner, fly and go. From Paris Corner, you can come back through Beach Road. Adayar, take right. In the left comes the Annapunga. Multiple paths. You got options. You can have a very fine-tuned path selection if you have LSDB. The other routing protocols don't have that complete database. The other distance vector protocol, they give only the best route. Your friend says, take one taxi via Mount Road, you come to what is that place called? Whatever. Before Adayar, you need to get down one stop or two stop before Adayar. You will see Annapunga. All Mani Mandapam will be there after that. You need to get out. That is what your friend will say. That only one route. Because that is the best route for your friend who lives in Adayar. He is positioning himself in Adayar, so he is giving you that route. But if you see from Meenambakkam perspective, there may be another better route, which you can even go by walk. When I was a small boy, I used to go walking to the Meenambakkam airport from Raj Bhavan through the race course. So when you have map only, you can take a very fine-tuned shortest path first. Shortest path. The very accurate shortest path. More granular in path selection is possible, not using distance vector, only by link state routing protocol. That's why OSPF is more popular than distance vector. Link state routing protocols are giving more granular path selection. Because you got the complete map, you can take more fine-tuned path selection. Not only that, if that path is blocked, because you got the map, you can immediately jump to another path. Immediately you can jump. So convergence time is also very less. If a path is blocked, look into the database. If you have another path, use that. If you don't have another path, what does that mean? There is no path exists. That's the only path. Yes, that's the only path. If there is another path, definitely linked state database will have it. So you don't need to query others when there is no path. If the map don't have a path, you buy a Chennai map, there is only one path that shows to that destination for that particular destination. If map don't show another path, which means there is no another path exist. It doesn't exist. You don't need to ask someone, wait for that block in the road to get removed. There is no other option. But that is not the case with the distance vector protocol. Distance vector protocol advertises only the best route. So when the best route is blocked, you have a doubt whether we have alternate path or not. So you start asking auto guys, is there any other alternate path to go to that place? Because you know that your map is incomplete. Distance vector protocol providing informations are like an incomplete map. Linked state routing protocol provides the complete map of the topology. So only a linked state routing protocol can do a fine-tuned path selection, accurate path selection, as well as fast in converging when a path goes down. Immediately it will pick another path from the database and recommend it to the routing table when the primary path goes down. What is primary path? The low cost path is the primary path. You got multiple paths. One path cost is 10, another path cost is 20. You choose the path 10. For example, D to B. I can go via A, I can also go via C. If going via A is 10, going via C is 20, the primary path is via A. What if both the path costs are same? Equal cost load balancing is supported. If you have 1,000 packets, all even will go via one, all odd packets will go via the other. So 500 packets via A, 500 packets via C. Equal cost load balancing is by default supported. How many? 4 equal cost paths. You can also increase the number of equal cost path support by using a command called maxpath. Depending on the version of the operating system, max path number will vary. Some will say 6, some will say 8, some will say 16. All right, so these are all the takeaway from this page. OSPF maintains this 3 table. Each router will send hello packets. Every 10 seconds. And if a neighbor is not saying hello, neighbor is considered dead after 40 seconds. And this is in LAN environment. In another word, broadcast environment. In non-broadcast environment, which is also called as WAN environment, hello packets are sent every 30 seconds. A neighbor is considered dead. 4 times of hello is always a dead timer. This hello packet only helps to discover neighbors. Every router sends hello packet. Your hello comes to me. My hello comes to you. So we learn each other as neighbors. And neighbors are maintained in the neighbor table, which can also be called as adjacency database. After forming neighbor only, they form adjacency. First they form neighbor, and then they form adjacency, meaning they start sharing the LSAs and LSUs. That helps them to build this topology table. In another word, the map called LSDB. After forming neighbor, the sharing of link state database using a summarized link state database called DBD, database description. The router shares LSDB in a form of DBD. More detail we will see when we do the lab. I'll show you. DBD is nothing but summarized form of LSDB. LSDB is too big, too detailed, too big. Sharing LSDB will consume a lot of bandwidth. So what OSPF does is, it is taking the summary of LSDB called DBD, database description, that is shared in between the neighbors, that helps to form a synchronized database between the neighbors. So each router can have now all routers and their attached links, and they will be identical, at least within an area. Yes, OSPF will have multiple areas. We learned in CCNA. Within an area, you can guarantee that all the routers will have identical database. Identical database. You see, if you are in India outline map is same, whether you buy in Chandigarh or Chennai, it is same. But from France, if you try buying India outline, it won't be that detailed outline. But France map will be very detailed there. What I'm trying to say is, within an area, database will be identical because you are within the area. You give more importance to local, less importance to other area. We do a lot of summarization when we advertise to other areas. So you cannot expect other area to have complete path information of this area. We do what? Summarization. Before sending to other area, we summarize the route and send. Within an area, you can guarantee an identical link state database. Fine. Next is the routing table. As we already discussed, SPF algorithm is going to pick best path, low cost path for each destination and recommend it to the routing table. This you already know. Why do we need link state routing protocol? Because this protocol have got more information about the networks than the distance vector protocol. This gives you the complete map of your network. As a result, the routers can make more accurate path selection for each destination. As we just spoke, OSPF have got two hierarchical network structure. One is the area called backbone area, which is also called as transit area for all other areas. Other areas are called as non-backbone areas or regular areas like this. Area 1, 2, and 3 are regular areas. Area 0, backbone area. It is only that 0 number can be a backbone area. No other number can be a backbone area. That's how OSPF is designed. Whether it is Juniper or Cisco or Huawei or ZTE or Huawei, whatever the vendor is. This is an industry standard protocol. It's only area 0 can be a backbone. All other areas communicate through the backbone. That is why backbone area is called as transit area. Backbone area is also called as transit area. Why? If one regular area want to talk to another regular area, only one hope is via backbone. C cannot talk directly to D. Even if there is a connection exists between these two, they will not form neighbor. Why? To form neighbor, in the hello packet, they share the area ID. This guy says, I belong to Pakistan. This guy says, I belong to India. What? India. I won't talk to you. That is what happens. They don't talk. Because this guy says, I am from area 2. This guy says, I am from area 1. Hey, we are all OSPF, man. We should talk. End of the day, it is OSPF area communication. No. There is a rule to play. The rule is area 0 can form neighbor with area 0. This end is area 0. This end is area 0. This end is area 1. This end is area 1. These two forms neighbor. This end is area 2. Area 2. These two form neighbor. This end is area 0. This end is area form neighbor. This end and this end is not same area. We will not form neighbor. And not only that, area 1 routes cannot be given to area 2. It can be only given to area 0. Yeah. Let's say you have area 2 here. Area 2 here. Definitely they will form neighbor. But area 1, this is area 1. This route will not be given here to this link. This link routes will not be given to this link. Why? You need area 0 in between. If no area 0, no transit, no routes are allowed from one area to another area. Area 1 to area 2 only way is area 0. That is how OSPF is designed. You always need backbone area. If not possible for G to communicate to F. That is why the backbone area is also called as what? Transit area. Can my fingers talk directly to the brain? Not at all possible. My fingers cannot talk to brain. Brain cannot talk to finger without my backbone. My backbone is a transit. That's how the command goes. Same way. OSPF, in order to be scalable protocol, this hierarchy is needed. This design, two-tier, two-level of hierarchy is must, because OSPF has got unlimited hop count support. OSPF supports how many hops? Unlimited hop. For that only, you need areas. If everyone is in one big cluster, even though the China is known as a highly densely populated country, it is not one. There are many states. Shanghai, Beijing. You got many divisions inside. That's why China can be that big country. So big, but still neat and tidy. Beautiful subways, roads, metros. How is that possible? It's because of the discipline of the government, honesty and straightforwardness of the government, and the small areas and different ruling parties in each area made that country prosperous. They are the one who supplies all goods to the whole world, both software and hardware. Such a wonderful big country is China. Beautiful, highly well-developed technology. You will see when you go there. So why do we need these areas? As I said earlier, OSPF supports unlimited hops, meaning one hop is one router. In one router, if you have two networks. If you have 1,000 routers, then 2,000 networks. If you have 10,000 routers, then 20,000 networks. You see, it is difficult to manage. That's why you need to put in small groups so that while advertising the networks of this area 1, you can summarize it and send. Instead of sending 200 routes, you just send only one route, summarized route. Just one route you advertise. For example, here you got 10.1.1.0/24 till 10.1.255.255 networks you have. Here you got 10.2.1.0 till 10.2.255.0/20. So here you're going to only advertise one summarized route 10.2.00/16. This is going to advertise 10.1.00/16. Just one route per area. Because you got area, you can do this. Because you got area, you have a boundary. Because you got a boundary, you are able to do the summarization. Yep. So we need boundaries to do summarization. பாத்தீங்களா இந்த கொரோனா வந்தப்போ எங்க போட்டானுங்க செக் போஸ்ட பவுண்டரியில தான் போட்டாங்க. பவுண்டரியில தான் போட்டிருப்பானுங்களா போட முடியாது. எங்க போடுறதுன்னு முழிக்க வேண்டியதுதான். ஒவ்வொரு தெருமுனையும் ஒரு பவுண்டரி, ஒவ்வொரு ஸ்டேட்டுக்கும் ஒசூர் ஒரு பவுண்டரி between Karnataka and Tamil Nadu. Boundaries will not be there if you don't have states, areas. Because you got on boundary CDE, you can do summarization for area 1 networks in C and send only the summary route to B. When you send summary route to B, B will only send that summary of area 1 network. So the routing table of these area will be minimized. Other areas need not to know a detailed information about this area. Why should someone in Jammu and Kashmir need to know about Talapakatti Biryani Street? He will not even eat Talapakatti. Why you want to give him information about Talapakatti to Jammu and Kashmir? It's useless, right? So you just give summarized route. South Indian food, come to South India. This is the route to South India. Boom. So to minimize the routing table entries, the detailed information is needed only within an area. If I am in Bangalore, I need to know where is Talapakatti because I am fond of Talapakatti, that mutton nalli. So I want to find where is the Talapakatti. Oh, in Kottanur, okay, that is in the corner on the first floor. Okay, good. But people in another area need to know Talapakatti of that area or A to B of that area. Need not to know the Talapakatti of my area. So we minimize, we summarize and send the routes to other area. And when a change happens, for example, there is some issue, what is it? Heavy rain. Heavy rain. It won't affect the entire country. It's heavily raining where? Inside North Bangalore. Why will you give holiday to South Bangalore? Or why do you give holiday in Kerala and Tamil Nadu? No, no need. So what is happening, because you have different areas, you can localize the impact of a topology change. If a link goes down, that need not to be updated to area 2 and area 3. Link is going down in area 1. It's unnecessary to send and waste area 2 and area 3's attention and bandwidth and CPU. So in order to localize also, you need to have areas. Otherwise you cannot localize. Because you do summarization, detailed LSA stop flooded. So you are no more sending 250 networks. You're just sending one summarized network. Right? This explains why we need two-tier hierarchical design in OSPF. OSPF unlimited support. Definitely there should be some order. There should be some proper steps taken so that routers won't have too many routes and suffer without CPU. We need to put more areas and do summarization so that you can minimize the size of the routing table. See, more smaller the routing table, more quicker the decisions will be made by the router. Smaller routing table will make your network more efficient network, fast network. Right? Now, these routers, which is a member of a backbone area as well as non-backbone area, they are called as area border router. That is where we do what? Summarization. And these two routers are internal to area 0, so they are backbone routers. This is an internal router to area 1, internal router to area 2, internal router to area 3, whereas C is a backbone, C is an ABR of area 1, D is an ABR of area 2, E is an ABR of area 3. Area border router will have at least one port to backbone and one or more port to non-backbone. You can also have like this. One router can be a backbone for area 2 as well as area 1. That is allowed. You have one backbone, area 1, area 2. So area 2 routes, let's say there is no connection here. Area 2 routes will go here, go to area 0 and come back to area 1. This is how it is. Area 1 cannot give to area 2 directly. Area 2, though it is one single router, with the help of area 0 only it gets distributed. That's the procedure. That's how it is designed. Right? So we'll stop here. We'll continue our discussion in our next class. What you have learned is OSPF can provide you more information than any other protocol, because OSPF collects the link state information, not just the best path for destinations. And also OSPF is having unlimited hop count support because of this hierarchical design, which is helping you to summarize, localize the detailed flooding of LSA stops, which improves the efficiency of your network. Any question?